There we go. Okay, so what I want to do is go through the two different types of questions that you're going to see. Okay, on page 1 of your activity today, and you'll do this all on sheet 1 of your spreadsheet, is I'm going to give you a statement, and from each statement, I'm going to ask you to just list properties or relationships that you can identify or derive given that statement. Okay, the properties should be either measurement related. I mean, don't just list, I don't need just simple basic properties. They're properties that are specific to that particular figure or statement. Okay, so the two examples that I'm going to give you is, one example, I might tell you about a figure. So if I tell you that ABCD is a parallelogram, okay, you don't need to draw it. I'm just going to draw it here as a reference. If you want, you can draw it on a separate sheet as a reference. But based on the fact that this is a parallelogram, okay, what properties have to exist in this figure? Okay, what does being a parallelogram tell you specifically about this figure by definition? Mia? Okay, so in this case, the one thing that parallelograms tell you is that opposite sides are parallel to each other. Both pair of opposite sides are parallel. So the statement that you would write would be AB is parallel to CD, and you can write BC is parallel to AD. Okay, the only other property, now again, you think about how it's defined. A parallelogram is defined as a quadrilateral with both pair of opposite sides parallel to each other. Or both pair of, the opposite sides are parallel to each other. So when you look at the properties of that, the only other property is that it has 4 sides, and that's not going to lead to anything. So all you would need to do on a problem like this is list this particular property. Now, if I expand it to a rectangle or rhombus or square, you're still going to include the fact that it's a parallelogram. So you'd include that the sides are parallel, but you might also say whatever the other property is. So for a rectangle, you might say all the angles are equal to each other and they're equal to 90 degrees. For a rhombus, all the sides are equal to each other, in addition to the opposite sides being parallel. Okay, so use all the properties that you can. Now, you don't need to defend your statement, but just to start to introduce the idea of defending every statement. In this particular case, we defend this by saying it's just the definition of parallelogram, that opposite sides are parallel to each other. Okay, let's go to one that's measurement-based rather than kind of the figure-based. Okay, here we have an example of WX bisects YZ at point B. Okay, so which segment is being bisected? Is it WX, YZ, or both of them? Antonio? Okay, it's YZ. So when I sketch this, if I'm sketching it to identify, okay, I'm going to plot my YZ first. So I know that point B is going to bisect this. So point B falls right here, and I can make this marking. That's the only information that I'm given on here, other than the fact that WX is going to pass through B. Is it going to pass through at a 90-degree angle necessarily? No, so I wouldn't draw it that way. Otherwise, you might be tempted to think that's a specific property of it. And is B going to be the midpoint of WX necessarily? Again, not necessarily. So I would suggest that you draw it so that you don't get confused or mistaken on that. So W and X. So here would be an illustration of this relationship. Again, don't read anything into it that's not given. And then your final step is to identify the relationship. So what we just said, that the segments that are equal are going to be what measures? Based on the fact that YZ is being bisected, that tells me what measures are going to be the same. Excuse me. So YB and BZ. Okay, so those are equal to each other. Is WB and BX going to be equal? Again, not necessarily, so you can't identify that. Now, if I was defending this, I would say definition of bisect. Okay, again, in the first part of this assignment, you don't have to defend your statements. You simply have to make those statements. Okay, now there's another relationship that exists in this figure involving the segment YZ. Amita, what do you say? Okay, so you could say B is the midpoint. Again, that would wind up being a definition of bisect. You could include that. Usually a statement like this is going to be a piece of information that's given to you, okay, but that's still an accurate statement. Okay, what about the relationship between points y, b, and z? Is there anything other than that's less specific than the fact that y, b, and bz are equal? And now remember, when you come up with relationships, they have to be based on definitions, postulates, axioms. Right? In this particular assignment, you're not really going to use axioms for anything. The only postulate you'd use is going to be, Alex, what would you think?
Well, I don't know if this is right, but would one be that y, b, z, and y?
Okay, so again, you don't need to be that that general. It is true. It's just like up here. You could say that this has 4 sides, but you don't need to state the general things. But let's take y, b, and z. Okay, what relationship do those have on that segment, or on that line segment? Okay, and even more specific to that, that means that the sum of the parts is equal to the whole. What's that relationship called? Do you remember? It's the last postulate we talked about yesterday, or it's the postulate we added. Okay, remember we have the relationship that the whole yz is equal to the sum of the parts, yb plus bz, and that's referred to as segment addition postulate. Okay, so by segment addition, we can write this statement as well as the variations on it. So we could say that yb is equal to the whole minus the other part. We could say that bz, the part, is equal to the whole minus the other part. Okay, and that's all defended by segment addition. Okay, we can do the same thing with the w, b, and x. Okay, so the only other relationships that we have here is that wx, the whole, is equal to the sum of the parts, wb plus bx. The part wb is equal to the whole wx minus the other part bx. And then the part bx is equal to the whole wx minus the other part wb. Once again, that's all part of segment addition. Okay, but those are the specific relationships that you should be able to derive based on that given statement.